with 2 different doses. So we use 120 ppm and 90 ppm. So some results that we obtained so far. First of all, we did just a regular lifespan using DDW without manganese treatment, and we didn't observe any increase in longevity when we treat these worms only with DDW. So as you can appreciate here, these are the concentrations that we use. So just the regular water, 150 ppm, then 120 and 90 ppm. So we didn't see any difference. However, when we pre-exposed these worms to manganese and then treated them for 48 hours with DDW, we observed, as you can see here, so controls are these black squares and the triangles are manganese. You can see this shift to the left indicating decreasing lifespan. And you can observe that the 2 concentrations that we use of the DDW, they were able to revert this decreasing longevity caused by manganese. So this was a very interesting result that we observed, and we decided to go deep to study the molecular, what would be the molecular pathway, what would be the mechanism. So we decided to look at DAF16 pathway once it's widely studied in C. elegans. So something interesting that we find was that manganese causes decrease in DAF16 levels, so that corroborates with the previous finding that we saw decreasing lifespan. And DDW, just when we treated the worms with DDW, we didn't observe any alteration in DAF16, which maybe explains why by itself it doesn't increase longevity. However, when these animals, they were pre-exposed to manganese and treated for 48 hours with DDW, we observed increase in DAF16 levels. So DDW was able to revert this decrease in DAF16 levels caused by manganese. So this was a very interesting finding that we observed. So looking downstream the pathway, we look at manganese SO superoxide dismutase. So this enzyme is downstream DAF16, is one of the proteins that it has its how can I say, the expression increased by DAF16 levels. So again, we observed this decrease in manganese SOD, which is related to the decrease in DAF16 levels caused by manganese. And we observed that at 90 ppm, DDW was able to restore manganese SOD levels that were depleted by manganese. Looking upstream the pathway, so upstream DAF16, we look at AKT, is the kinase that phosphorylates DAF16, inhibiting its activity. And we observed that manganese also increased the AKT levels, which would cause increasing phosphorylation of DAF16. And again, at 90 ppm, DDW was able to decrease this AKT level significantly. So everything connected to the DAF16 pathway. So considering all these results that we obtained, we decided to go deep to look at use genetical approach in order to see if only DAF16 was related to this pathway, to these effects of DDW. And we decided to use DAF16 mutants. So these worms, they don't have DAF16, they don't express DAF16. So by themselves, they are already more sensitive, and they have shorter lifespan when compared to wild types. And as you can observe here, still manganese causes decreasing lifespan, and this is possible because manganese acts in different pathways, not only DAF16. So that's why we still see some decreasing lifespan. But what it was surprisingly was that DDW at the 2 tested concentration was able to revert again this effect caused by manganese. So this result indicates that it's not only DAF16 that's involved in the anti-aging effect of DDW. So maybe other pathways are involved and not only DAF16. So this, I think, it's in agreement with several findings showing that DDW doesn't act only in one, doesn't have only one mechanism, but like several in the whole cell. So this last figure is just like to show this decrease in lifespan. So here we just have control wild type, and here this dark squares we have just the DAF16 mutant, and you can see how different it is, the lifespan. You can see the number of days that's highly decreased. But this is just to illustrate what we found. So just some conclusions of this work. So we observed that DDW has anti-aging activity in C. elegans exposed to manganese. This activity relies partially on its ability to modulate DAF16 pathway. So as we observed, it's not only DAF16. The use of mutants showed us. DDW treatment recovered DAF16 and consequently manganese superoxide dismutase levels, indicating that the antioxidant proteins modulated by DAF16 are also recovered by DDW. The manganese-induced increased levels of total AKT were diminished by DDW, suggesting that the whole DAF2 pathway is involved and not only signals downstream to DAF16. So DDW doesn't act only in DAF16, but in the whole pathway. And the use of the DAF16 mutants demonstrated that other pathways, most likely, we believe that SKN1, which in mammalians is called NRF2, which is also related to longevity pathways, may be also involved in this anti-aging activity of deuterium depleted water. I would like to thank Dr. Michael Ashner. He's my PI, my mentor. I'm a postdoc. I'm here to replace him. He couldn't come, so I came here replacing him. And he and Dr. Gabor, they started this work. I think we started like 9 months, 10 months ago. So it's not a very long time that we have all these results. I would like to thank HYD, Vanderbilt University, and also our NIH for the funding for this work. So thank you.
Thank you. Any questions or comments, please?
Have you ever changed the DDW level during the treatment?
You mean like when I was treating them?
Yes, maybe from 120 to 90 after maybe 8, 9, or 10 days.
So you see that the lifespan is very short.
Yeah.
It's only 18 days. I think if you consider that, if you like consider how long rats live, I mean 2 days is a lot for a worm. Like for 18 days, 2 days, I think it's a lot. We were thinking to try longer, but considering that after that, the worms, they go from L4 to the adult stage, they start to have a progeny. We don't want the progeny to be treated. We want to see the effects on the worm. So after that, they start to have a progeny, and that kind of, it's not good for the treatment, for the lifespan at least. Mm-hmm. Yeah.
Any other questions or comments?
Have you ever tested any other molecules which can compensate the toxicity of manganese? So
not in C. elegans.
Mm-hmm. So could you say any example for another something, molecules, compounds, which can have the same effect like the DDW when the C. elegans had been treated with manganese?
Yeah. So like not against manganese, but because we are just studying the toxicity of manganese. We didn't come to see to reverse the effect. That's the first study that we've been doing with DDW. But like in the C. elegans literature, you can see there are several compounds that have been tested to increase lifespan.
Okay, but these you have never tested the
against
compensation
manganese.
of the manganese? Okay.
Would be a good positive control, maybe.
Okay.
Yeah.
Yep.
Any other questions or comments? If there is no, then we would like to thank all the speakers of morning session for their contributions. And there will be a lunch break, I guess, and we will continue at 1 o'clock. Is it so?